Welcome back, Algebra 2. In this video, we'll be going over the solution to the problem shown on the screen. So we're told that the height of a kicked soccer ball is a quadratic function of the time it has been in the air. The ball reaches a maximum height of 64 feet after 2 seconds and also contains the point 4, 0. So we're going to use this information to write an equation for the parabola. And since they don't specify, we're going to write the equation in vertex form. So the first thing I notice is that this problem does not have a graph for me to reference. So I'm going to go ahead and draw one out, and you should as well, just to give yourself a visual and to start putting key pieces of information onto the graph so that we know how to set up our problem. So we're told that the height of a kicked soccer ball is a quadratic function of the time it has been in the air. So reading that means that time is going to go on our x-axis and height is going to go on our y-axis. I know that we're working in seconds and time because I'm told that the ball reaches a maximum height at 64 feet. So I know we're working in feet after 2 seconds. Okay, so that's how I know we're working with seconds and time. So now let's go ahead and do that and give us a parabola to work with. Okay, so the other key piece of information I see is that the ball reaches a maximum height. So since I know I have a maximum height, I know that my parabola has to be opening down because I'm going to have a maximum point right here. So I'm going to go ahead and draw in an upside down parabola with a maximum point right here. Okay, so we're told that it reaches a maximum of 64 feet after 2 seconds. So that means I know that the vertex is 2 comma 64. They're actually telling us what the vertex is in a not explicit way, because we're told after 2 seconds, so 2 is going to be our x value, the ball reaches a maximum height of 64 feet. So 64 is going to be our y value of our vertex. And it also contains the point 4, 0. So I'm going to go ahead and label that. So that tells me that after 4 seconds, the ball has a height of 0 feet, which means it's back on the ground. Okay, let's go ahead and start plugging in points into our vertex structure. So the vertex form of a parabola has this structure. And I'm going to go ahead and plug in 2 and 64 in for h and k because that's what we know so far. So I don't know what my a value is. I'm going to leave that as a. Okie dokes. All right. So now from here, we're going to use that other point to help me figure out what a is, what our stretch is. So I'm going to plug in 4 in for x and 0 in for y. So I have 0 equals, don't know what a is. I'm going to plug in 4 in for x and copy down the rest of the equation. Okay, so now from here, I want to start simplifying and working backwards to help me solve. Okay, so then from here, we've got 0 equals a, 4 minus 2, that becomes 2. So we have 0 equals a times 2 squared plus 64. We're going to go ahead and square that 2. So 2 squared is just 4, so I have 4a plus 64. And then we can go ahead and solve. So I'm going to subtract 64 on both sides of my equation. So I have negative 64 equals 4a. We are going to divide both sides by 4. And so we get that negative 16 equals a, which makes sense that it's going to be a negative number, right? Because the negative means that I've got a parabola that's opening down. Okay, so now I've got all the information I need to go ahead and write the equation for my parabola. So y equals negative 16 is going to go in for a. And then we're going to plug in our information for our vertex. And we're done. Thanks for watching.